Okay, so how do you choose K? Because it's K in your tables, right? What's the optimal K value? This is for hyperparameter tuning. We will discuss this in more detail in the next sessions, but for now, at a high level, it's basically you trying various you have lots of values for K, and then just see empirically which one of them is the best. And for that to happen, you have to have another set, which is the value set. So you split your data into 3 sets. You have your train, your val, and test. Train is for training purposes. You just train your model with it. Validation determines which configuration or which K value is the best. And then test is for the score. So your K could be K1, 2, 3, 4, 5, up to you. You basically have, like in this example, 5 different models. The first model is KNN, where K is equal to 1. Second model is KNN, where K is equal to 2, and so on. You compare all of them, and your val set is for that. Validation set is for that. It says this, say for example, K is equal to 3 is the best according to validation set. This is sort of like your quiz. Tells you that this one is the best performing one. So you use K is equal to 3. And then you go to the actual exam, which is the test set. Now you get your score. Yeah, the best performing based on the hyperparameter, yeah. And then you predict based on the model that was determined as the best in your validation set. Still following? You have to tackle a lot. Maybe we'll do the coding next session. Thumbs up if you guys are still okay. Oh, just one. So you guys are not able to understand that. I think I can unfortunately see you guys doing thumbs up. I can only see a few. Anyway, let's continue. Yeah, setting calculating hyperparameter. We'll have to discuss hyperparameter tuning now a little bit. So first, example, choose hyperparameters that work best on the data. This is bad. You never do this. You're supposed to have train and test set. So, yep, this is the wrong way of doing an experiment. Now, idea 2 is the typical one, easiest one. That is correct. You split your data into train and test. But it is still bad in the context of calibrating hyperparameter. But you'll see this particular configuration being done on other cases. If you're not going to hyperparameter tuning, then you're okay with train test. In the first 2 tasks that I'll be giving you, no hyperparameter tuning yet. But anyway, the reason why this is bad is because you are already optimizing for your test set. It's like saying you are optimizing your study for the exam, which should not be the case. You should be able to actually generalize it as a whole. You're not supposed to focus on just the exam. That's sort of cheating. So the other idea is to have train val test, which is what I have shown you earlier. This is the correct way of doing things. So you study or you train using your train set, and then there's going to be like a quiz or validation check on which configuration among them is really the best, and then you evaluate it finally using your test set. Yeah, this is good. This is good. Another configuration actually is to do cross-validation. This is what we actually use out there when we do projects in the academic industry. But for now, we're okay with this train val test, or just train test if no hyperparameter configuration. This one, well, if we can, we'll just do this. So it's easy actually to do, but if you're not comfortable with it yet, then just go with train test or train value test. But yeah, this is what we use. This is really the best setup. So what happens in cross-validation? You split your data into folds, and then you try to, well, what you're doing with this particular fold here is you omit it in your data set. You only train your data set using this fold 2, 3, 4, 5 here, and then check how it performs in your fold 1. And then you do it for the other configurations. And then you get the average of them. The average of them. And then you apply it to your test set. You get the square. I suggest not really doing this for now because it might be too much to take in. Just do the train test and train value test. We'll do this in more detail in the future sessions. Yep, this is good for small data sets. But not we can use in deep learning because it's too computationally heavy because you're doing so many training. I mean, lots of experiments. Okay, disadvantages and advantages of KNN. Computations happen at real time rather than during train time. And this is very computationally expensive. It considers all the attributes and they have equal weights. The advantage, fast training time. Basically, there's no training. You're just storing it. You're just saving it. That's really fast. You're doing nothing. You're just copying. Easy to implement. Yeah, very easy to implement. Oh yeah, that's for later.